Or just write that down, don't erase that.
Let's say f of x is equal to 2 raised 16. I want you to try and tell me what f prime of x is.
It is a constant, so what is
So
it?
there is a reason why I started with this because your brain is going to immediately jump into the power rule and do this. If f of x is x raised n, it will be n times x raised n. So n is 16. 16 times 16 minus 1. 16.
I didn't do that much.
I mean, you were worse, Chief.
Yeah, I had both down, I had both down, so I was.
16 times 2 raised 15.
You were
That is
super
incorrect. Why?
No idea.
That is completely incorrect. It's a constant.
2 raised 16 is a constant. It's a number.
Yeah, I had that down.
65,536.
Look at that.
If you take the derivative of 2 raised 16, which is 65,536, which is a constant, what do you get?
Zero.
Zero.
Yeah.
A constant does not change.
It's beautiful and it's simplicity. Actually just started going around counting victims.
I want you to try this problem. Try. So I just want to see if you guys remember limit laws, because when I started, limit laws will directly apply to derivatives. Everything that worked there will also work here. Some great cases will be a bit tricky compared to others. So if we have a bunch of functions in addition, we wanted to take the limits, we took the limits of individual things. If we had a constant in a limit, we pulled the constant out before we took the limits. Are you paying attention? So those are some of the rules. If you follow the same rules here and use the power rule on top of it, what would the derivative be? I just want you to try. If you get it wrong, perfectly okay. So at this point, if you do difference quotient to find the derivative, I can only come to one conclusion. You like pain. Now that I know power rule, now that I know limit laws, there is no need to go and use the difference quotient and taking the limit, because that is already associated that to a derivative. What does one of the limit laws say? If you have a bunch of functions added together, you can apply the limit for this, that, and that. I can apply here, I can apply there, I can apply there. So if that holds true for limits, it must also hold true for derivatives. Yes, rule number 1. So I can take the derivative of this term, that term separately, add them all together. Limit law number 2. If you have a constant multiplied to a function, you always take the constant out before you apply the limit. The constant stays as is. So here, 4 is a constant, so when you take the derivative, you can keep 4 out of the derivative. I'm going to write it in detail this one time, but once you get it, you don't have to write everything in detail. Derivative doesn't touch 4, just like a limit wouldn't. So it's right here. Derivative of x with respect to x. And derivative of 1. 1 is a constant, so it would be +0. What is the derivative of x with respect to x? 1. 1. You could use the power rule to get the same answer. Here, 3 moves to the front, decrease the power by 1. So 3 minus 1, 2. 4 times 3 is 12. X raised 3 minus 1, 2 plus 1. That is the derivative. Now, here is something that students will make. I've seen people do in Calc 2, Calc 3, differential equations. Derivative of x with respect to x. I've seen people put 0, I've seen people put x, but the answer is 1. If you cannot see it, using power rule, this is an informal way of thinking, but easy to understand. Dx over dx, what do you get? 1. Yes. Number divided by the same number is 1. Use the same logic as 1 twice. So, of course, informal way. Formal way is you're trying to find the rate of change in x with respect to x. It has to be 1. Are we clear?